Okay, welcome back. Next up, we have Nikos, who's going to talk about IT, IoT, and mobile security. So, welcome, Nikos. Over to you.
Hi, everyone. I hope everyone had a fun time with the previous speakers. I'll be talking to you about securely storing and transmitting information on mobile and IoT devices. And this is a story in development. So who am I? I'm Nicolas Boeckh. I'm a student from Switzerland. I usually go by Atomic Nikos on the interwebs. And these are all of my socials. So when we're talking about cybersecurity as a whole, I found that really rarely translates to projects that involve some form of development, be it just development for applications or developments in IoT. And so the map here, which tends to describe the cybersecurity domains, isn't really applicable because, as you can see, if we are using a form of chronology that goes from ideation to a potential incident, where ideation would be the start of your idea when your project is born, the development itself of the project, the production of the project when all the building blocks have been added together and you're starting to put it out there, educating your users, to finally deploying your project so that it's available to everyone, to finally having your incident, which is something we don't usually consider and should actually consider in one of those workflows. So I'll ask you to keep an eye just on the background of the previous mind map, because that's the thing that will be changing. And as you can see, all the nodes that relate to cybersecurity domains are the ones changing over time. So from ideation to development, to production, to deployment, and then finally to incidents. So the idea wasn't that you read everything. The idea was just to see that it spreads everywhere. So maybe we can talk about finding a root cause, right? I circled a few of these nodes in red, and just by thinking a little, we could possibly determine that, I don't know, developers are to blame. That might be a contentious statement. It actually is, because we're also talking about managers. We're talking about the rest of the hierarchy. All those people are involved at some point in the development process, and they are also responsible for certain decisions. Now, why am I giving this talk? Well, I stand at a certain crossroads at a kind of a Goldilocks area between development and InfoSec. I am a developer first. And so I'm in that very niche area of actually having some awareness on both sides. Some developers are also InfoSec adjacent. They have some knowledge of InfoSec. They know how to secure their forms and these kinds of things. And that's also pretty nice. But often when you're in an enterprise situation, you get the big gap between InfoSec and developers. And that is actually scary. It leads to some situations like an incident happening and cybersecurity professionals not taking liability because they weren't invited into the process. And that's something we tend to try to avoid. Finally, I'm at a certain nexus of domains. I study in information systems and service sciences, which sounds big. It involves development, management, ethics, security, and regulations, all bunched up in a big ball of knowledge, although it isn't equal time. It looks something like this. I also pursue InfoSec and OSINT as, on the side, and I'm trying to kind of migrate there over time. So what are we going to talk about? Well, I'm going to give you a small brief overview of the terminology I used, in the title of the talk. I'm going to kind of say why we would want to reduce the risks from the people involved to the technology at hand to the risks that both of these produce by existing, by doing mistakes, and then the fallout that happens if you don't consider these risks. I'm going to talk about risk mitigation. And then finally, I'm going to do a small back and forth of things I've actually heard being said and things I probably should have responded at the time. And that is going to kind of be the flow of our talk. So, the ecosystem. I talked about IoT. I talked about mobile devices in development. I talked about information transmission, and I talked about information storage. So these things kind of scale down in abstraction, so I'm going to take it in the reverse order. Information storage, for the basics, it's just ones and zeros stored somewhere, either in RAM, in SSDs or SD cards or hard disks, and in some form. It's either raw, so it could be direct sensor output and that kind of information, or it could be processed, like text files or Excel files or JSON files, or just databases as well. And now that we have information, we might want to actually transmit it. So the nice people that defined networking defined the OSI stack, which is a stack of 7 layers going from physical, which is the closest to your physical appliance, to the bare bones network, to the highest layer, which is the closest to the user. If we clean that up, it looks something like this. And when you're a part of a network, maybe as a mobile device, and you're trying to send information, usually go through some form of physical media, which itself doesn't necessarily need to present information to the user. When we're talking about IoT, we're talking about peer-to-peer connections, which involve more layers than just your physical media, because IoT can also display stuff. It can just interact, it can just transmit some base information. And that is something we are going to talk about. In terms of transmission itself, the information isn't usually just broadcast in the wild. Usually you have some form of packaging, which in itself, like these protocol data units that are used to package information, this one is the Ethernet protocol data unit, give some form of structure. For example, this one has a destination address and a source address. The data itself, kind of like a letter, you put a letter in an envelope. You have some postage seal stamps, which would be your flags for your Ethernet PDU, and also an integrity check, which would then be your seal for your letter. Right. There we go. Mobile devices in themselves at a base level, it's just something that stores and transmits information, which in itself also allows some form of user interaction. At the most abstract, that's what it is. And if we're developing for such a device, we can specify some additional requirements, like the need for networking, the need for API calls, the need for information storage. And this has been made more accessible to developers around the world, because for platforms such as Android, used to only have Java to develop for them. Then it migrated to Kotlin, and now you have multiple languages that can do that. For iOS, it's the same thing, from Objective-C to Swift, and now multiple things can develop for them. Some cross-OS development stacks include React Native or Flutter, and this availability and this accessibility to mobile development has two effects. It's easier to develop apps, but it's also harder to find the vulnerabilities. In terms of IoT, well, the Internet of Things doesn't just include one thing. It includes smart everythings. It's fridges, it's watches, it's coffee machines, it's teledildonics. The talk I linked here is SME at BeerCon2, talking about hacking dildos. So that's always fun. So is that what we're talking about? Not really. We're talking about IoT clusters. An IoT cluster is usually a cluster of IoT devices which are service-centric. They all do usually one to a few things. For example, we can talk about an IoT sensor grid that measures carbon monoxide levels in the city streets. These IoT clusters kind of form the IoT Triad, where your IoT devices will connect to mobile devices or servers or whatnot via certain forms of communication, such as potentially GSM networks, Wi-Fi, long-range radio frequencies, Bluetooth, NFC, and the like. There's multiple options. So why would we want to do this? Well, first, we're going to talk about the people at hand, the technology on which it's based on, the risks that those produce, and yet again, the fallout. So users, quite simple infographic. They're your best friend. They're also your worst enemy. If you've heard of that user described in the comic, it's a user that always has ludicrous problems. So the basic morality is to love them for the income they bring, but hate them for the problems they bring. And in terms of people involved, you also have developers and managers and the rest of the hierarchy. Because at some point, at some level, before or when you reach the big Cs, after an incident, someone might actually try to let everything burn down just to save face. And that is an issue you might need to contend with. So if we're talking about the technology at hand, we have information storage, which is a basic element when we're talking about IoT, about just databases, data dumps, servers, log files, and APIs. All of them have that thing in common. And what information storage has in common is that it's stored on some form of physical media somewhere. So if just that is exposed, you're already in danger. In terms of information transmission itself, it usually goes through some form of medium. So we can talk about wires like USB, Ethernet, and the like, proximity wireless like Bluetooth, NFC, stuff like that, and wireless like Wi-Fi, like GSM networks, and the like. And an important part of information transmission is the availability. When you're talking about a service, it needs to be available. Otherwise, people will miss it. And finally, information transmission does rely on protocols, which define data structure, which define the need for authenticity of the data, for authentication of the data, for the integrity of the data, and finally for the security of the data. How secure is your data? So now that we've talked about the people and the technology, we can just have a small intermediary conclusion that all of this is a huge attack surface. So let's talk about risks. Well, in terms of IoT, there's a saying, the S in IoT stands for security, which has been said from times immemorial and said recently by one of the beer farmers. Let's talk about storage. SD cards are vulnerable to physical access. They have an easy I/O. Most computers have an SD port or some adapter that allows that. And they contain possibly juicy files like SSH files, which probably shouldn't be stored on such a device. Microprocessors themselves, well, you can get the bytecode off the microprocessor and then find all the static values within, or also just reverse engineer the code. In terms of transmission, we can talk about Bluetooth Low Energy, which is a plain text byte stream, which can be passively observed or attacked. And the existence of Bluetooth profiles, which kind of help with interoperability of devices, actually helps attackers more than it does developers, because they can say, okay, this responds to that protocol, so it will have that type of data, and it kind of helps. Tautology Zero, so fellow happy hour card holder and Buckfast enthusiast, actually did an entire tweet thread that was taken and posted on the Pentest Partners website about hacking a Bluetooth Low Energy smart lock. An interesting read. Long-range radio frequencies. Some data is transmitted over that. Well, if you have any compatible or LoRa receiver, you can grab all the data. Finally, in terms of Wi-Fi, you have packet capture and all the other standard risks which apply. In terms of storage itself, well, we go in terms of mobile devices. The storage, it's the same thing as IoT, except you have way more files. You might store some music on a mobile device. You might store some videos, some juicy files, some configuration files, things you might not even know are there. And that's something that to be accounted for. If you root or jailbreak your device, well, you give access to your cache data, or you can get access to your cache data, which is usually where apps hide all their juicy secrets as well. Some Windows or Mac OS applications, such as My Phone Explorer amazing actually allow access to a portion of the cache data, the one that is not intrinsically private. And that also allows attackers to have a certain idea of the scope. If we just talk about the most recent issues between Epic Games and Apple, for example, where iOS users had to jailbreak their devices to install Fortnite, well, that could have been a part of the, it could have been an issue at some point. So is your 8-year-old video game addict a part of your threat model? That's a question you need to ask yourself nowadays. And then in terms of memory, well, memory issues can occur. For example, if you don't handle concurrency correctly, you can have some pretty funky and destructive results, which is not something you might want in an application. In terms of transmission, well, we already talked about Bluetooth Low Energy and Wi-Fi, but we can also talk about NFC. So Ben earlier talked about skimming. Well, that's a pretty big risk that people need to contend with. In terms of services, well, phones let you access a wide range of services, from geolocation to storage to sensors, which in of itself doesn't seem like a horrible idea. But if you consider the usage of such sensors to possibly predict sleep patterns, well, if you hijack that type of application, you can possibly say, oh, that person is sleeping. Let's go rob them or do other horrible things to them. So yeah, that's an issue to contend with as well. In terms of servers, well, that's something I'm not an expert at. It's actually not in my area of knowledge. So here's someone doing something with web servers, and Google is your friend, as always. So story time. So a Dutch cybersecurity company recently did a study on smartwatches. So they bought a smartwatch that allows them to track children, so their own child, for their child, quote unquote. And so they registered the app, registered it, installed the app, and did everything correctly. They then observed some communication between servers and the app, and so just installed BurpSuit in the middle. So BurpSuit being a web application pen testing tool. And so what did they notice? They noticed that it was using an ID to grab the geolocation data. And what happened when they changed the ID? Well, the location data changed. So of course they tried to replicate this in a browser. That didn't work, which brings out an issue of the level of authentication, which was correct, but not of authorization, because they weren't allowed to see that data, technically. And so this might not seem like a big issue, except that it exposed the location of potentially hundreds of thousands of children, which in itself is pretty horrible. So have a happy Halloween horror story. This issue, which I just mentioned, has in the meantime been fixed, thankfully. So let's talk about fallout. Well, fallout can be measured by 3 metrics, kind of. The amount and sensitivity of the information that was exposed, the speed at which the service recovered, and how the entity responded. So that would be the company that produced said application. If the information is very sensitive and the entity responds horribly, it erodes the trust in that service. If the information is sensitive and the service takes a while to get back on its feet, it erodes the feeling of privacy that is generated by that service. And finally, if the entity responds horribly and the service recovers slowly, it erodes the credibility of your service and your company. If you have all 3 box checked, you have something called an omnishambles, which, if you're a part of the big C's of your company, gives you an occasion to yell. So let's use a subject case, the hypothetical right match singles scenario, which was envisioned by Lisa Forte, and let's discuss that. So in that scenario, a dating service has a massive data breach, which exposes not only its users' data, but some of their private documents. And what happens is that the CEO of the hypothetical company doesn't disclose it to the relevant authorities or to the users. And finally, when they're facing legal action because it's been leaked, they go nuclear and just take down the service for a while. And this kind of checks all the massive omnishambles boxes. So that's something that is a pretty good example. In terms of fallout, we can also just quantify fallout by how the entity responded. I'm going to use 3 small test cases. For the good, well, you have like an information disclosure in some type of new service in an API, which is solved quickly. High bug bounty, that's pretty good. Information disclosure of certain users of a form, solved kind of slowly, that's okay. Some things take time. But if you have a really chatty API, which exposes all of its users' data, like in the case of Giggle, which happened in September, you get something called a dumpster fire, because especially if you say that there was no incident, that's actually pretty horrible. What didn't help in this case of PR disasters is that the CEO of said company also, well, antagonized the InfoSec community, which is not a great move on their part. So let's talk about risk mitigation. Well, in terms of IoT development, in terms of storage, it's avoiding to add upstream critical files to your IoT device. That would be SSH files, it would be configuration files, stuff like that. Because if you have an SSH file that allows me to gain access to the entire company's repositories, which is something I've seen in the wild, that's a bad move. If you have operations logs, that would be storing the entirety of the data you generate. That's also a bad move, because it's better to just store state changes in general logs and then error descriptions and the data that produced the error in error logs. That allows you to kind of segment the information. Finally, nice thing is to not produce anything that can't receive firmware updates, because even though your device is 100% secure now, you have no clue how it's going to evolve in the future. In terms of transmission itself, well, you can define and use standards for protocol data units, like the Ethernet packet we talked about earlier, like IEEE 754 float representation, integers, characters, etc. That kind of allows you to have a certain control over the data you're sending, mapping it out, maybe detecting some errors in the format, and check maybe if you can detect some modification. Another underlying advantage is also that allows you to compress if you're using binary representation of certain data types, like the example shown here. A few bonus points you can get is like if your framework is extensible. If at some point you need to add some form of data types or you're pushing your firmware update, well, you can also modify your PGU with minimal repercussions. Another good point is potentially validating the integrity of your data, which is pretty nice. Another idea is possibly adding a timestamp in some form to avoid replay attacks, so that some data isn't replayed or some data isn't sent back to you over and over. Right. In terms of mobile development, if you're one of the 90% of devices that either has iOS or Android, well, that's pretty nice as an operating system. Well, you can have some pretty funky ways of storing preferences, like, I don't know, JSON files somewhere. Most OSs, including the two I've cited, actually have a default library for that, have default methods for handling that. Same thing for opening files. And you can actually hide files, sandbox them in your mobile application. Finally, if you're handling serialized data, it's preferable to use an internal database system for input, output, and concurrency issues. In terms of memory management, well, you can use single object instance design patterns, which sound like a complicated thing, but basically it means that one instance of an object, a container for data, is accessible at any moment from anywhere, which is pretty convenient, but kind of is limited in terms of access, because you don't know who is accessing your data, what part of your app is accessing your data. Another part is potentially asynchronicity, which solves concurrency issues, which helps you serialize some operations that take a lot of time, and overall a pretty good thing. Finally, in terms of development workflows, you have waterfall and linear development, which is a pretty old way of dealing with development in projects. They produce very few tangible products. You have an app that's being developed, that's all. So if you can't evaluate the security of your app, you can't evaluate its quality as well, which is an issue. In terms of agile development, well, the lack of security counsel on the artifacts you produce during every sprint is also an issue, because you might snowball yourself into vulnerability hell at some point. So let's move on to things I've heard. So I'm going to take the case of an information security professional, a developer, and a manager. So it's an app. It needs to look good. We'll sort out the data later. Yeah, big no. It's easier to adapt UI to a service than the reverse. If you just have a UI and nothing going on behind it, and you're trying to rush implement a service, you're going to have issues. In terms of software, so they installed our software. That means that they want to share the data they generate with us. Well, that's an issue too, because, well, if you've seen Juan's talk about GDPR, that's a big no-no, at least in Europe. And you can't just assume what users want from your service. In terms of data persistence, data persists for 1 second. What's the worst that can happen? Well, Bluetooth for driving has been a thing at least since 2003. It's been talked about at DEF CON 11. So yeah, it is still an issue. We don't use application IDs with our location data. What do you mean they can be tracked? Well, I'd invite you to look at the privacy project in 2019 by the New York Times, which actually shown that location data aggregators from like ad services have access to a ton of location data information. So potentially tracking people in the White House and the Pentagon and Congress, stuff like that. So it's pretty important. So yeah, location using and transmitting devices can be traced. Managers saying they can't coordinate security suggestions with the rest of the tasks. Well, first of all, the term of ideal is probably going to have you yelling internally, but please be politically correct about your response. Using a mock-up based workflow is pretty good, where you mock the data calls, and once your service is ready, you just add in the correct data calls. So yeah. So what are our conclusions? Well, IoT is the stuff of nightmares. Don't tell your CISO about it. Improvements in the field aren't standards yet. It'll take a while to get there. Security is a matter of being consistent on all fronts. You may have the best web or API security systems in place. If your IoT is vulnerable, you're vulnerable. And my own 2 cents are to have an InfoSec professional assigned to the dev team, which will help you catch errors along the way. A hidden conclusion is that since IoT is a great part of the backbone of networking nowadays, it's an imperfect backbone nowadays. It's very vulnerable. We need to handle that, because many enterprise systems, many people rely on IoT nowadays. So yeah, this talk is available under CC by SA, which is an open license. And thank you to all these fantastic people. You can find me here.
That's brilliant, Nikos. Thank
Thanks.
you very much for that. Did we capture any questions? I can see one already. So the question here from, I can't even figure out how to pronounce that. How do we recommend managing the risk of IoT devices in a corporate network?
Don't connect anything to an outside network, first of all.
Fair.
Is big point. And don't have anything that is accessible from any outside point. If you're going to have something, broadcasting some information, make sure that it's not accessible by public visitors or things like that.
Yep, good advice. I don't think we've got any other questions, and you've absolutely nailed the time, Nikos. So well done now. Yeah, you have indeed. Okay. So thank you very much. Well done, and yeah, great stuff. Thanks a lot.